Next up on our docket is the PACSAT update and demonstration by Mr. Bill Reed, the PACSAT project manager. So big round of applause, please.
Good afternoon. My name is Bill Reed, NX5R. I think this is the 5th AMSAT project I've worked on. But this is by far, in my mind, the most exciting. And if you look at what we present this afternoon and think about not only where we are, but where we could go with it, I think there are some really cool things out there. So let me start by giving you an overview of this first phase of the project. Okay, PACSAT is not a satellite. PACSAT is not a satellite, it's just a payload. But it is a single CubeSat card, 92 by 92, that performs these PACSAT functions. We're an Ascent project and we are 100% open source, so you can see everything we're doing by going out to GitHub. This is a concept drawing that we started with back in July of 2022. And what it shows is what is on that 1U card. We have 4 AX5043s as the uplink. In front of that is preamps and filters and a splitter to get the signal to the 5 receivers. So we have 5 uplink receivers on 2 meters feeding into a 570. And for the downlink we have a single 5043. Yeah. And of course, we've got filters and a power amplifier for that. This is a very simple block diagram, and there's really a lot more to it than what's shown here. This is the software. Pretty simple concept. Just roll it together. Free RTOS, 3 state machines, a whole bunch of processors. So it's really, I'm being facetious, it's really quite complex, but too close. But we'll learn more about it here this afternoon. 4 uplinks. 4 uplinks, 5 5043s, 4 uplinks, and 1 downlink. Okay, we're 100% open source, and you can go to these URLs and look at all the docs for our project and all the source for our project. But the easy way to get there is just to go to github.com and search for PACSAT. These will come up. Like I said, I've worked on a number of AMSAT projects, but this one is really different. In the past, it's sort of been like herding cats, getting people assigned tasks and following what they're doing and make sure everything comes together. These 5 guys are incredible. Since 2022 until today, we are about 80% complete with this project, and I think that's incredible. Bob Strickland's going to speak to us in a few minutes about the circuit board he's done. He's doing the layout. Burns and Chris are both of the software guys, and Chris is going to give us a demonstration of a working PACSAT. We have a satellite over on that table. He has a ground station over here. The whole thing is working today. Corey has done a lot of the file system work for us. The file system is critical in order to store messages on the satellite. And Jim has done some of the hardware. He's developed the PACSAT prototype for us, and he's done a great job of cleaning up little things for us. So this is an incredible team. Kudos to the whole team. They have basically built a whole PACSAT from July 2022 to today. Okay, I'm going to turn it over to Bob Strickland. While Bob is coming up, are there any high-level questions I could answer? Kip?
What does it do?
Aha, yes, of course.
I know the name, but I don't know what it
Yes,
does.
well, that's what Chris is going to show you. That's the whole point of the demo. Anybody else? Not only look at what Chris is going to demo, but think about other things that could be added on to that. Andrew?
Hey, Bill. What type of baud rates are you thinking about for this payload?
Initial baud rates are going to be 1,200 up on the 4 uplinks and 9,600 down.
Okay.
On our demo here, we're doing 9,600 up and down.
So the 1200 is AFSK, Bell 202, blah, blah, blah?
Yep.
Okay.
But it's programmable, and you can change it on the satellite in flight.
Is there any way to pass audio through the receiver and the transmitter?
This is a digital product.
Well,
Digital.
that's not answering the question. I'll point out that on AO16, that capability was there, and it made a whole second life for the satellite. I'll also point out that UO14 started out as a PACSAT, and once the computer quit working in it for PACSAT purposes, it was used as an FM repeater. It's also very useful from a command standpoint, that if you have one uplink that's not working, you can pass audio through it and try to identify what the QRM is.
All I can say to that is that I think the hardware design could support audio if it was programmed to do that. But this is really a payload. So if there's also an audio capability, it would be the rest of the satellite. Now there is a link to the IHU, and so we will probably be downlinking.
Trying to point out reasons why it would be a good idea
Yeah.
to include it based on 30 years of flying PACSATs already.
Okay. Bob Strickland.
Okay, I think that those comments are good and worth thinking about, but the problem is that we have moved forward with the technology and the chips that are being used here. In those earlier satellites, the transmitter and the receiver was all linear, so it was easier to do that sort of loop back function where you could run through the thing. But now the chips that we're using are so highly integrated that there's a lot of processing going on within the chip, and the data is being passed around through I2C bus or SPI bus. And so you could digitize voice or linear type signals and try to pass those around, but still everything's got to be functioning. And you're trying to do diagnostics. It sounds like your idea is, but it's worth keeping in mind. But this sort of is another block diagram similar to what Bill was talking about. We're coming in through a 2-meter antenna, and then we run that through a preamp, a filter, and then we divide that single antenna into a signal to feed into 4 different receivers that are going to go back into the processor. And then the processor does its job and sends a signal back out through a single antenna and through a single transmitter chip. So we do have 5 of these digitizing radio chips in there that are in the loop of the thing, so to speak. We have several voltages that are involved, and we have a pretty good chunk of memory because we're moving files up and down off of the satellite. The other functions are pretty much similar to what's typically required in a satellite. So I've done this PC board layout just in the standard footprint. It's a 6-layer board, and it's used or built with the KiCad open system. So if you want to install KiCad, go to the links that Bill talked about. You can download it and you can open it up and look at the actual layout, or you could grab a piece of it if you wanted to use it for something for one of your own personal projects. But you can see the 4 receivers are over here, and then the transmitter's down in this area, and then there's an amplifier, a PA, and then this is a filter to be sure we're staying within our band or within the range of output that we want to be in frequency. And we got a bunch of stuff over here for power and things like that. And this is what the physical layout looks like in KiCad, which is pretty neat to be able to see the thing. I've got more work to do to try to get these packages lined up. Working with the manufacturer right now to try to build a few of these boards for us. There's about 300 parts on this board. Some of the earlier projects, we did them all ourselves. There weren't so many parts on the board, but these days it seems like you're cramming more stuff in, and it's a lot more difficult to hand build them. I'm pretty proficient with surface mount, and I've got all that kind of capability, but rather use pick and place for some of these parts that are so precision. But it's very similar to the other board too. A lot of this came from the work that Zach did. I just sort of took his stuff and pushed it around into what was needed here for this project. So any questions for me? Yes. We've got a mic coming.
Is this compatible with the ACDS that we have on the Golf Tee? Because it has that same interface. And so if we put it on Golf Tee, it would have to be up there just underneath the ACDS. Or this board. Oh,
Well, the connectors.
that
yeah,
4 by, I can't remember what it is.
It's like a
header.
PC 104 it's
The
called.
PC 104
this
header.
connector. And that's a
There's
format
also
that-
one on Golf Tee
Yeah.
for that
Okay.
gyroscope system.
Yeah, this is based on a document that Burns brought to our attention. We're very fortunate to have Burns helping us out. And I tried to follow that same document. All the connections on these pins on this connector try to follow the ones that were defined previously, although there's some extras that I've got now. There's stuff on there too that weren't needed on this board. So there's some overlap in there, but yes, I tried to move in that direction. But keep in mind, this is really a prototype development type board to see what we can do. Power's come up several times in here. I'm constantly thinking about how much current different chips require and trying to make decisions about how to do things to minimize that power, because we do have that limitation of whatever those solar cells produce, that's all we're going to have. So we may find out, for instance, in the long run, we can't support 4 receiver chips, maybe only 2. There's a lot of work that could be done by somebody about just understanding what the thresholds are of people that are in the community for being able to use the satellite. And can you do just a little bit more? Maybe if we did a little bit more power output, for instance, we'll open up more people that could work with the satellite. But these chips are also very versatile and can operate at many different frequencies and different baud rates and different modulation schemes. So lots of tests or learning can come out of this board in the long run for us. Any other question? One more
So I
question?
would assume then that the 4 receivers are so that you can switch or either have simultaneous uplinks to the satellite or on different frequencies, or are they switchable?
That's all correct. You could have all 4 simultaneously listening. They're going to be buffering their received data, and then they send an interrupt to the processor that they've got data to be processed. And they're really running relatively slow compared to what the capability is on the processor, although trying to slow it down, because if you run that processor slower, it uses less power. So yes, the answer is yes. Yes, sir.
Thanks. What's the frequency range of the receivers? And what's the
They'll
filter
go
set at?
up to, I think it's 850 megahertz, something like that.
And how far down do they go?
How far down?
Yeah.
They're going to go below 2 meters, and we want to do 2 meters. So.
Okay, and the filter is set at, what's the filter? Is it the digital setup or is it hard? What's the range on the filter?
I'm sorry, I couldn't hear your question.
What's the range on the filter?
Well, the filter's designed to be narrow band. You know, we haven't picked the exact frequencies we're going to use in the long run, but I can put different filters on these boards to accommodate testing.
Okay, all right, thank you.
Okay.
Not a question, but a comment. I'm the youth initiative guy, and I am so excited about this for engaging kids, because kids don't talk today, they text. Okay? And working with students at the University of Arizona, I can't tell you how many times we've had them out in the field and they move from AOS to LOS, holding their handheld, waiting for an opening in the chatter. They feel rude, you know, trying to break in. But you sit these kids down with a tablet and some kind of sound interface to a handheld, they go crazy. I mean, we miss Bob Bernuga's PACSATs or APRS sets so much. The kids had so much fun with that. I can't wait to see this fly.
That's a real interesting comment, and it is interesting to kind of have perspective on the technology shifting like that and paying attention to it, and flowing with it. That's good.
Burns, did you want to say something, or Burns Fisher? Burns Fisher is one of the software architects, and a lot of this stuff has been ported over from Gulf, so you'll see some similarities there.
Oh, geez, I don't have anything to say now. Thanks, Bill. Yeah, one of my goals in MSAT, yeah, I know. One of my, I was on the radio at one point, you know, I know how to do microphones. One of my goals in MSAT is to try to share software around a whole bunch of projects. We started out with Fox, and I admit that I should have gone back further to find software that was already written. But so we've got the Fox software. The Fox software was ported more or less and tweaked and amplified and so on to Golf. And what I really thought I could help with on PACSAT is to start out with the Golf software and use a lot of that same stuff. And I think we've done that. That's what I first started out doing, was taking the Golf software, tearing out all of the stuff that we didn't need, but leaving the operating system, leaving the drivers, leaving the way that the processes, tasks are set up, and all that sort of thing. And I think this has been pretty successful. Chris has been able to use it effectively. So that's what I was happy to be able to do. And I'd like to also, by the way, give credit to Eric Skoog for the documentation about what pins get used by what devices. That was another of my goals, is to try to bring Golf stuff into PACSAT, because most of the PACSAT people are pretty much PACSAT mostly. So I wanted to try to bring some Golf stuff in, and again, not reinvent the wheel. So I think we've been pretty successful with that, and that's one of the reasons that we were successful in making so much progress, is because we only reinvented wheels that needed to be reinvented. So that's all I had to say. Any questions? Any questions software-wise? Okay, thanks.
Yes. And now I get to do something I've always wanted to do my whole life. I get to become a satellite. So watch me. I'm going to go over there and I'm going to launch in about 5 minutes. And this gentleman, Chris Thompson, is going to be the ground station, and he's going to talk to me. So watch this.
All right. So I'm bravely going to try and do a live demo. I'm Chris Thompson, to a potentially skeptical audience from what I'm hearing so far as well. So I'm Chris Thompson. I'm G0KLA, although I now live in Canada, so I'm also VE2 TCP. Although we have the satellite running with my US call sign, which is AC2CZ. So I seem to be collecting call signs. Let me set the scene then a little bit. We have a satellite that is potentially orbiting the Earth. Potentially it's orbiting the moon. Maybe it's hardware sitting on the gateway. It's a store and forward device. We can store data in it. We can pull that data down later at any point. We can pull it down based on a set of parameters. You can think of it in some ways like an old-time bulletin board system, but it's not really like that, because a bulletin board you sort of log into and do things interactively. With this, we need to know what's on the satellite. So we have a ground station here. This is the ground station software. And how do I make it point? One of these buttons? Yeah. This area up here will contain a listing of everything that's on the satellite. We need to know sort of what's on the satellite so we can interact with it. And typically you wouldn't interact with it during a pass. I mean, you can if you're sitting there at the radio, but typically it will collect the information, and offline you'll say things like, okay, I want to download these files. I want this data, and then it'll go and get that data for you. And in the bottom here, we'll see the interaction with the satellite. We'll see things that are going on. And the ground station we've got set up here, we've got a Kenwood D710 radio, so it's a full duplex, 2 meter, 70 centimeters radio. We've got a DigiRig sound card going into the laptop. So that's it in terms of the ground station. And we've got 2 meter and 70 centimeter sort of small dummy antennas. So Bill, if you plug in the satellite, we're going to see a couple of things happen. The satellite is going to come over the horizon, as it were, and the ground station, as soon as it hears the satellite, is going to request the directory, the list of contents on the satellite. It's going to send it a command, and it's going to get, hopefully, that list back. So if you can... AOS, yeah.
Quick one, Chris, you say it's going to request it, does it have to have a certain signal strength, or does it just start asking right away?
It has to decode the packet.
Yeah, that's okay. Here goes.
So it gets a message, PB empty, and it gets a message open. So it tells it that the PACSAT broadcast is available for business. But it should have automatically, of course, transmitted the directory. Now, why didn't it do that? Live. Because it's a demo. It's supposed to request the directory. Bill will tell you this was all working earlier. Nah, it always says that. It's a Windows thing, I bet, because I just plugged it in just a second ago. So you can see that it's receiving. It's got the time packet. The time is correct. We just received telemetry, so we can see on the telemetry tab. Well, it doesn't look like we received telemetry, does it? We received the time packet, but not the telemetry. Okay, 1 second. We're going to kill Direwolf and just, you know, if you tried restarting it, speakers USB sound card. It looks like it's correct. It's the playback that's not working. It's not 100%. Okay. This might have to be an offline demo for people to see. Let's just try once more. We're gonna cheat and just try this other version here. Okay. So that transmitted and got the directory, came down in a whole set of packets. You can see here. This is really just the mechanics of how it's working. It isn't really important to the user. We've got a list of headers, and it's just the headers. It's not the contents of any of the files. So it may collect tens or hundreds of files, however many files are sitting on the satellite. So we might offline decide that we want a certain file. So this file here looks interesting to us, maybe. That's the AMSAT bulletin. We can give that priority 1 to be downloaded. And on the next pass, or if you're still in a pass, it'll automatically start downloading that file. You don't have to be there for that to happen. That's just about a 13K file, It's coming down at 9600 bits per second. It's also a zipped file. Things are automatically compressed. And if we open it up, we can see that it is, in fact, the AMSAT bulletin. So we just got all this data from the satellite in about 20 seconds or so. Let's say we've got a file like this one here. This one pretends it's a satellite that's orbiting around the moon, and it's cached its data somewhere, perhaps in a system that's got better antennas pointing back towards Earth so that we can download it. And this was with partner one, some university partner that's partnered with us maybe to get that data back. What they might want to do is just set up a rule to download that data. So I can set up an equation that says anything that's sent to call sign partner one, which I better spell correctly, then I want to download that automatically. So it puts that rule in automatically. So that would have been downloaded as soon as that was available. On the next pass, if there's more files, that would get downloaded automatically. And you could then have a program that automatically processes that data. And this is just some, sorry, I got a program telling me to take a break. This is just some binary data. You can export that data. You can process that data however you want to. Lastly, it's a system where we can upload data. So that data perhaps got uploaded by another spacecraft, but we can also upload data from the ground. So I could, reply to this message here, and I won't reply and include it, although I could. I'll just keep it short. Great message, 7-3, Chris. And as soon as I click send, the ground station is going to connect to the satellite, and it logs in and connects a full connection, and it'll upload that file. And you can see that it says here in the abstract down below that it's a little difficult to read, but that it logged in and that it uploaded it in 2 packets, and it gets a data end, and it successfully uploaded that data. If we now again request the directory, then we find there's now one more header here, and if we were to download that with priority 1, then we'll find that that file will come down as well. There's also another file here which is an image, so I'll mark that to be downloaded priority 2. So it'll download those as soon as it has the availability to do that, and they come down. That one comes down pretty quickly. Just want to see if we've got some of the telemetry. So we do have some telemetry here that's being broadcast. There's a couple different ways we can do telemetry. This is telemetry that is being sent all the time. Think of that as a sort of safe mode type telemetry. We can also store whole orbit data telemetry, experiment telemetry in files on the spacecraft and download them. This is telemetry that's being broadcast. So we can see, for example, the 4 receivers. Only one of them is operational. 3 of them are marked as off. I'm not using the full hardware board here. We're just using a prototype board with only 1 receiver. And we've got the transmitter. You can see the temperature on the computer, for example, and we can plot graphs of these and so forth. So that's pretty much it. Just downloading that last file, which is an image file. I'll open that up as soon as it finishes, which it has. And we can see that it's just a picture of the radio chips on our board. It comes down again in about 40 seconds or so for a 25K image. So but that could be a camera image. A larger file could come down over multiple orbits. It picks up seamlessly. If you miss data in the file, when it requests missed pieces, it knows exactly the holes in the file that are missing, and it only requests those holes in the file. So it's very, very efficient. And because it broadcasts it, many stations can receive it at the same time. People don't have to re-request the same data over and over, so it makes an efficient system. Badale.
Is the underlying protocol still, okay, so is the underlying protocol still Harold's PACSAT protocol, or have you guys done something new and different?
The underlying protocol is still Harold's PACSAT protocol.
Awesome.
There's no reason why we can't enhance that in compatible ways, but it's exactly his protocol. The uplink is all FTL0 protocol, just uses the uplink parts of that, which is, I think, was common for the PACSATs, historical PACSATs. Question at the back?
Chris, from a functionality perspective, how does this differ, or will it differ from FalconSat?
It's very similar to FalconSat. FalconSat was, I mean, a much bigger satellite. It was about this by this by this, okay? I don't know what that is in size, but, 1.5 feet square. This fits on one board, 10 centimeters square. So obviously you've got to add batteries and PA to that, but it's a miniaturization of the same sort of concept that you could then fly along with other experiment partners. But it's an ascent project, so make up your idea of what you think it might be useful for, because it could be useful for lots of things. Question? Oh, there's one over here first, Barry.
Yeah, I'm just wondering here, I'm confused. You said that it could transmit down a picture. Where are they getting the picture from?
Yeah, the picture can come from an onboard camera. The picture can be uploaded by another station. That other station could be another satellite, something which doesn't have the power to beam that picture all the way back to Earth.
Okay, so
or it can be hams on the ground who are sharing images for fun if we wanted to do that as well. All of
it's
those
just
options.
basically a store and forward
It's a store
digital
and forward,
satellite.
yeah, it's a data platform.
Okay, thank you.
Okay, I think I saw two here. First.
How much storage is planned to be on this?
Yeah, and what type? So we've prototyped it with MRAM, which we've found to be very reliable on the other satellites. I'm not an expert on exactly why it's reliable, but it's been very reliable. I think the initial design is to have 4 chips, and they can be sort of 4 megabytes each or so. But there's no reason why we couldn't potentially have more chips now if we wanted. I know that FalconSat had about 16 megabytes of RAM on a RAM disk, and that was pretty useful for storing images and data. We certainly would want several megabytes so that we could store pictures and images, and so that it's worthwhile getting things down over multiple passes. The prototype has hardly any RAM. Actually, it's quite useful to test things with a very small amount of RAM. So we've got, I think, 16 or 32K of RAM at the moment. You can test it filling up and hitting the extremities and so forth. Yeah, Barry.
Since you're using the D710, which is a packet radio dual band, are you using any of the features of the D710, or are you using a separate interface going into your computer?
Yeah, I'm using a DigiRig interface, so it's just a sound card interface. And I'm running that into Direwolf as the packet TNC on the ground station.
So in terms of the radio, the D710's packet capability is really not needed, or could it be used if the user wanted to add it?
It's not needed. It could possibly be used. I have to think about that. You need, the ground station has to be able to connect either through a serial cable or through TCP to what it thinks is a KISS TNC. That's how the ground station is written. So,
Chris, what's the power consumption?
don't know. I wrote the software, so I'll leave that to the hardware guys.
Any idea, Bill?
A lot of that depends probably on how much transmit power we have. That's probably what'll be the biggest thing. And we're running this demo at 9600 bits per second. If we run all the uplinks and downlinks at that, no doubt that'll consume more power still. The radio chips, by the way, do 125 kilobits per second, so there's nothing stopping us experimenting with faster
Bill,
speeds as well.
That's 150 milliamps at 3 volts, 3.3? 5, got it.
So do I understand correctly that there would be 4 different uplink frequencies in use? Is there any provision for the software to tell the ground station which of those are open so that it can be switched automatically?
Yeah, so when it transmits, it says open A here, you can see. That tells you that receiver A is open and available. And if there were 4, it would say open A, B, C, D. And if one of them wasn't there, that letter is missing. So that gives the ground station the opportunity to know which channels are open and available. And I forget whether I coded it so that it puts the call signs on there. Some of the PACSATs used to put the call sign on there as well, and some of them didn't. But yeah, the mechanism is there for the ground station to be able to work out what's a clear channel. Now, clearly, we'd then have to be able to retune your radio and so forth. And I'll admit, I did write the ground station, but that is not written. That code doesn't exist.
Chris, I think I know the answer to this. It's me. I just wanted to give you a chance to say it for Frank and all. If you're a kid and you want to send text messages to somebody around the world, you can. Am I correct that you can just say, okay, this is to certain call sign, and on the other side you can say, tell me all the messages that are for me?
Yeah, you can definitely set up a rule that says download all the messages that come from this particular call sign. If you're, exchanging lots of messages with somebody, you can do that. You can also, there's no reason why the digipeater wouldn't be on to just send APRS messages. PACSAT did that. It becomes a cross-band digipeater as well, so people who like to use APRS can use that in parallel with this type of solution. We haven't just enabled that functionality. I guess written the code for that functionality, but that's not the most complicated part of the satellite, so we would definitely have that envisaged. Yeah.
I saw SHA in the code, like SHA hashing. Are you using that for error correction just to make sure the file is intact?
So there's quite a few different ways that error detection is done. The SHA algorithm is for commanding. When we send commands, it does God, I'm going to get the name, an HMAC 256, which I think uses the SHA algorithm with a secret key, but it doesn't transmit the secret key. So that's how we do the commanding. For the file integrity, they have a checksum, and they have a checksum both for the header and for the body of the file, and those are used to tell you both whether you've got single event upsets in the file that have happened on the satellite, and also when a ground station uploads data that it's that it's good data before the satellite sort of commits it and puts it in the directory. And that's in addition to the fact that in theory, the channel is error-free, okay? Because it's got error correction and so forth, and retries when data is uploaded. Any other questions?
I have LOS here.
Yeah, LOS, you can unplug it. All right, thanks everybody.